Hi, I'm Isha.
I'm Annika, and we are EcoPerks. Over 519,400 tons of food waste goes to landfills every year in Minnesota. We need to reduce this amount. With less food waste in landfills comes fewer negative environmental impacts. As food waste breaks down in landfills, it releases methane into the atmosphere. Addressing the high rates of methane emissions is one of the steps needed to reduce the warming of our climate. Unlike the anaerobic decomposition that takes place in landfills, the composting process is an aerobic process, which means that less methane is released as a result. Disposing of our food waste in the garbage is a tangible problem that is impacting our environment. As college students, we've noticed that ourselves and our peers have an especially hard time adopting composting as a habit. So we ask ourselves, what's missing? What is stopping students from actually composting? We surveyed the student body and found that the majority of students do not compost, the main reasons being a lack of access to a compost bin or drop-off sites, just not knowing how to compost, or feeling that composting is too much work or simply not a priority.
So based on our research, we discovered that we need a bridge between students and service providers to give students the resources and motivation that they need to properly dispose of organic waste. And our solution is EcoPerks, an app that allows users to earn rewards for composting while connecting them to the resources that they need. Here's an overview of our app prototype, and there's a link in the chat box if you would like to click through. We have included informational pages to teach how to properly compost, where to get a bin, drop-off locations, and pickup opportunities. From there, people can track their compost by taking a photo and inputting an equivalent value, which earns them points. And then they can take these points and use them for coupons at local restaurants and stores while reaching their personal composting goals. With this app, students will have the resources, ease of use, and motivation to start their green life journeys. Our vision for the future is ambitious, but we know it can be done. We believe that with the increased use of our app, we can have a bigger impact on our local community. When we expand our app to be nationwide across all campuses, we will be able to shift the cultural norms of organic waste management all across America and finally feel like we have positively contributed to the fight for climate change reform. So, are you ready to cancel climate change? Thank you, and are there any questions?
I love this idea. We've played around with some apps at UMD to get people to try to increase their habits. Can you say more about why you selected only composting as part of your app? Because I know there are apps that do multiple kind of eco things, and how you narrowed it down just to compost.
Yeah, we figured composting was something that's tangible, that's easier to track. So that's kind of our like going off points. Sometime in the future, if we find a way that's easier to track other green behaviors, we would love to add that to this app and encourage people to make their lives green overall. But compost, and like we mentioned at the beginning, landfills are a really big problem. And being able to start with something small like composting can get people started on that transition to a green life.
Yeah, and just to add to that, we also originally kind of looked around at just our fellow students and saw that most people are recycling. It's kind of become more of a social norm, but that composting really is less accessible and just less of a common behavior among students.
Is composting available to students in dorms and res halls throughout the U of M?
Yes, it is.
I thought it was great. Really like this idea. My wife and I do collect our organics, and we've been doing that for about the last 3 years. And what surprised us was how much less waste we have once we started collecting organics. Is really amazing. And so I think this is a terrific idea, and I like the idea of an app. In part, we have a little magnet on the side of our fridge, Every once in a while, I have to go back and say, okay, can we put this in the organics or not? And so the idea of an app that just has that information could be really, really helpful. So a really great presentation. Thank you.
Thank you.
What are the next steps between the prototype and getting it out there to people? And are you partnering with the Twin Cities Sustainability Office or the res halls, or what's the plan?
Sure. So right now we're actually finalists in the ACARA Challenge competition. And so that is coming up next week. Basically, if we do receive funding, our next plan is to look further into actually developing the app, possibly hiring someone to do that for us. And then we are going to start small, just advertising to student groups, pages around the U of M. But we have explored the idea of looking into a partnership with the university, seeing if they would open up their organics drop-off sites to the wider student body so that people could bring their compost from home to a central location to drop it off there. And we have also looked into partnering with Brightside, which was a previous ACARA Challenge winner, and with the idea that while they drop off their produce, they would also pick up the compost of people who don't have access to their own bin or a drop-off site. So that's something that we might pursue in the future as well.
And then just so we aren't relying on ACARA Challenge funding, we've also looked into becoming a U of M club because they get money every semester. It's smaller, but then we can also partner with other clubs that could help build the app.
I would highly encourage you to reach out to Hennepin, Ramsey County, connect with the waste part, recycling part of the counties. They may even be able to have funding for something like this because organics collection is something they're really, really stressing. And that might be an opportunity. So well done.
Thank you. We'll definitely look into that.
So you mentioned potentially making this a U of M club. Have you considered reaching out to existing clubs that work with, similar aspects and incorporating yourselves into another club?
We haven't explored that option. We have talked about reaching out to people who have sustainability majors or minors and recruiting people that way. But yeah, that's definitely a great option to look at.
All right, thank you guys very much. Our next presentation will be from Griffin Peck.
Do you have the slides for my presentation? Awesome.
Yeah, okay, go.
All right. My name is Griffin Peck. I'm a student at the Morris campus, and I work in our Office of Sustainability here. And today I'll be presenting about sustainability efforts at our campus and the importance of benchmarking to long-term sustainable development, and along with exciting future developments at our campus. Next slide. So first, I wanted to quickly introduce you to our sustainable buildings that we have on campus. First, we have the Green Prairie Living Community, which is a student residence hall that was built in early 2013. And it is a LEED Gold building. LEED is a green building certification that is put out through the US Green Building Council. And it has a lot of benefits to the building, but also it means that the building was designed to be run in a sustainable way. We also have the Welcome Center, which is one of historical buildings on our campus, and it was renovated in 2012, and it is also now a LEED Gold building. And it was one of the first buildings in the state to utilize chilled beam technology in order to cool the building. And then we also have the Humanities Building, which was built in 1953, but recently renovated to be more energy efficient. It also utilizes chilled beam technology, but it uses it for both heating and cooling. Next slide. So what is benchmarking? So benchmarking is something that people who are interested in sustainability, or even who aren't interested in sustainability, but just want to look at their usage and how their buildings are consuming different resources. It's a tool that you can use to track that over periods of time. And so some of the different metrics that we benchmark include electricity usage, natural gas usage, hot water and steam usage, which is used in heating and cooling our buildings, along with the chilled water. And then we also track renewable energy generation on our campus. And to do this, we use B3 benchmarking along with some other software like Google Sheets to track all of that. And B3 is actually a benchmarking and energy tracking system from the state of Minnesota. And any public building that receives public funding has to use B3 benchmarking. And so almost every building in the state that receives public funding is on there. And it's just a really cool way to view sustainability in our state and across different campuses and other public buildings. Next slide. So why is benchmarking important? There's three big reasons. First, we are able to quantify sustainable buildings and their performance. So one of the big things that I'm looking into right now is whether or not our sustainable buildings on campus are being operated and maintained in a sustainable way. Because while you can build a building or renovate a building and call it a sustainable building, it is very difficult to track whether or not it's actually performing in a sustainable way. And so benchmarking allows you to look into the metrics and then create data representations of what performance in a building looks like. And you're also able to compare it against baselines for the building so that you can decide whether or not the building is actually operating in a sustainable way. Benchmarking also allows you to address specific operating problems that hinder sustainable efforts. A good example of this is that if a building has solar panels on its roof, that is a sign of a very sustainable, it can be a sign of a very sustainable building. But some solar panels have heating elements in them to melt snow and ice off of them. And if those are left on all winter and they're never turned off, those consume a lot of energy and detract from the building's sustainability efforts. And so with benchmarking, we're able to identify these problems and have an effect on them. And then you can also identify buildings that can be operated sustainably, even if they weren't designed to be. So there are other buildings on our campus that don't have sustainable or weren't designed to be sustainable buildings, but through benchmarking, we can track how they are operated. And then you can find out ways to make them more sustainable. Next slide. And then I just wanted to quickly run through some of the sustainability things that we have on our campus. We have a solar PV array outside of Green Prairie, which is 20 kilowatts, which helps to provide a lot of the energy for the building's consumption. We also have 2 wind turbines on our campus, which help to also further provide energy. We have solar thermal arrays, which heat our swimming pool in our regional fitness center. We also have a biomass gasification plant, which helps to create energy and heat our campus. And then we also have solar PV arrays behind our science and math building. And we also achieved carbon neutrality in electricity this past summer. Next slide. Oh, it looks like my time is up. I'm so sorry about that. You can just skip to the next slide, and then I can answer questions.
Griffin, were you able to determine any specific improvement projects that were, I guess, the low-hanging fruit from an environmental perspective? Things that across all buildings tend to make the most sense, both environmentally and economically?
Absolutely. So this isn't my first experience with green buildings. That's something important I should say. I was involved in a LEED certification project at my high school, and I did that for my senior year of high school and the year after I graduated. And through that process and also through my work with the Office of Sustainability, a lot of things are just like things you don't often think about. So it's just like lighting or unplugging electronics when you're not using them. And so using LED lights, and then also finding ways to make natural light as like use more natural light rather than turning on lights. Those are some like very cost-effective things that you can do. And then also just when you're tracking maintenance, you can also find things that maybe the maintenance or facility staff is doing that's not sustainable, and then just have a conversation with them, and then they can change how they operate the building at usually very little to no cost. So.
Could you speak to, in the benchmarking work that you've done, that have you been able to identify problems? You mentioned, for example, the solar heating elements in a solar array could get left on, but could you give examples of the kinds of problems that you found because of benchmarking that you were able to solve and improve the performance?
Absolutely. So we're actually still in the very beginning stages of benchmarking and getting data updated. One of the things that the person I work with, Troy Goodna, who is the director of sustainability at our campus, has talked to me a lot about is garbage in, garbage out. So making sure that we're not putting garbage data into B3 and double checking and triple checking that it's correct. And the biggest problem that I've actually found so far on our campus specifically is that a lot of the meters meant to track compressed steam usage, hot water usage, as well as chilled water usage aren't actually performing in the way that we hope that they would. And that can be for a variety of reasons, whether they're older or they're not calibrated correctly. And so that's one of the first like big problems that we're actually tackling with the facilities and with our campus is trying to find ways to either update these meters so that we can get good, reliable data, or recalibrating them, or finding ways to track data without implementing high cost solutions, something more low cost. Yeah.
And then have you used trending data as well?
Trending data?
Yes.
I
Trending of data to show that we were here and now we're performing here, and there's got to be a reason why.
Absolutely. So I'm still in the very beginning stages of working with this project. My work with the Office of Sustainability is going to continue over the summer and through the next academic year. But one of the things that we do know, one of the ways that we are able to see that we are operating more sustainably than we did in the past is our carbon neutrality achievement, which happened over the summer. And that had to do with some back-end bureaucratic things that we changed. As far as trending data, we use baselines in B3 to track building sustainability. And so in some of our buildings across campus, like in our science and math building, we were able to, it is operating more sustainably now because we were able to see that the people who operated and maintained the building didn't know which air handling units controlled which classrooms. And so when it was time, when someone wanted to heat up or cool down a classroom, oh yes, these are my photo credits and then credits for the presentation template, sorry. The Office of Sustainability was able to go in and track which air handling units go to which individual classrooms and rooms in the building. And then we are also able to, we were able to know which classroom to heat up and which to cool down instead of just kind of like guessing it. So that's one of the big things that we've been able to do too.
Thank you. Good presentation.
Thank you.
Just curious about the biomass gasification plant. What's the input on that? Is it ag waste, wood waste?
Absolutely. So since we are at the Morse campus, we are situated in one of the most agriculturally productive regions across the country. And so we use a lot of ag waste for our biomass gasification plant. Specifically, we use a lot of like corn waste because that's like the really big agricultural product out here. Yeah.
Thank you.
Well, thanks.
Griffin, do you want to talk a little bit about the battery project that you didn't quite get to in the presentation and how that fits into the overall picture at Morris?
Yeah, absolutely. So this summer we're installing two 10 kilowatt vanadium flow redox batteries, which I know is kind of like a lot of big words, but basically these are batteries that can be used for energy storage. And since we have a 20 kilowatt solar array outside of Green Prairie, what we are planning on doing is linking the solar array directly into the batteries so that if we are not using all the energy coming off of the solar array during the day or on really sunny days, we can store that energy and use it later. So sometimes our campus sometimes experiences blackouts. So they could be used in an event like that, but they could also be used at nighttime to help supplement energy usage when the sun isn't shining. So, and we're having some of the first batteries of these types installed in the state at our campus. So it's a really exciting development.
Will there be any sort of interface that students can see within the Green Prairie building to see maybe how much has been produced and how much they're using to help them kind of manage their energy use and really make that effective?
Absolutely. That's something that we're looking into at the moment. We don't have a lot of ways to do that. I know in the past, prior to the pandemic, they would have like monthly or once a semester meetings to talk about energy use. That hasn't happened this year because of everything going on. It's just made a lot of things more difficult. However, it's something that we're definitely like looking into. Also, one of the things that I've been using a lot and I think is a good resource to get out to anybody who's interested in energy usage is there's this website that was developed I think by the Twin Cities campus, but it has all the buildings on every campus on there, and you can track energy use in real time. So that software is already set up. It's just finding ways to make it more accessible to people.
Thank you very much. That was an awesome presentation.
Thank you.
Then we are going to move on to Lita Albrecht and Catherine Tomaska.
Hello, my name is Catherine Tomaska.
My name is Lita Albright.
And we are both juniors in Bioproducts Biosystems Engineering. And today our student group, the Food and Bioproducts Engineering Organization, will be discussing an ongoing project we've started this year that focused on designing a bioplastic composter.
Next slide. Okay, so obviously we have a problem with plastic in the US and globally. Since the 1950s, our plastic production and consumption has been increasing while only recycling a minuscule amount of our plastics. Although COVID this year has shown us that we depend on plastic a lot, that means that a lot of our plastic enters our environment in some way. Obviously, so about 8 million tons of plastic enter our oceans annually. This is equivalent to setting 5 garbage bags full of trash on every foot of coastline around the world. So plastic obviously causes catastrophic damage to animals, our soil, water, and air, and overall human health. Next slide. So we are obviously looking for an alternative to these petroleum-based plastics. Bio-based plastics have been a theoretical solution and are now coming into fruition. We hope to reduce carbon emissions and degrade plastic further into non-toxic elements. Not all bioplastics, which come from renewable resources like plants, especially corn, Not all bioplastics are biodegradable, but a few, like polylactic acid, are. So this means that given the right conditions and the presence of microorganisms, fungi, or bacteria, they will eventually break down into their basic components and blend back into the earth. More specifically, PLA can be composted under proper conditions. So this will quickly break PLA down, but it's important to note that industrial composting, like it says, can only happen industrially and not at home. This will be important, like we talk about later. Next slide. So polylactic acid, just a little background. It was introduced by NatureWorks, which is run out of Minnetonka, Minnesota now, which is pretty cool. Like I said, it's derived from renewable resources such as corn through fermentation, and it's a promising solution, except that it only degrades quickly through high temperatures, so around 140 degrees Fahrenheit, and that isn't a temperature that common composting like in your backyard is ever going to get to. So we need to do that industrially. Next slide. So overall, this is a problem because oftentimes people don't really recognize the different kind of plastics and how to deal with them. Oftentimes PLA or other biodegradable plastics get mixed in with our recycling streams, which causes problems. So we're hoping our solution is that if we make bioplastic composting, especially for PLA, more accessible to the common household, this will open up bioplastics and biodegradable plastics in a new way, and hopefully solve a lot of problems with plastic consumption. Next slide. So some of the basics of composting are that we have to get a lot of balances right. So making sure we have good feedstock balance between green and brown materials, moisture content, those high temperatures that we were talking about, and the temperatures have to be extended for a long period of time. And then also maintaining oxygen flow so that we have aerobic breakdown instead of anaerobic breakdown, which produces methane, which is obviously not what we want. Next slide.
So for our student group, we first began with background research on composting during the fall semester. We were able to meet a few times in person, during which we ran compost tests under controlled temperatures. So we ran an initial test where we placed 3 tubs in an oven at either 60 or 70 degrees Celsius, and the tubs were filled with a combination of soil, wood chips, food waste, PLA strips. And after 1 week, we found that the PLA in the 70 degrees Celsius tub was fully degraded, but there's very little moisture. So keeping these tests in mind, we then went into the design phase. You can go to the next slide. And on the left side, you can see the design from 3M, which are the people that we kind of inherited this project from. And they used a 55-gallon tub, but had some issues with having the plastic fully degraded. They also used a band heater and then a pump for the water. So for our design, we used a 32-gallon outside container and placed a 20-gallon container on the inside. And then within the outer bin, we placed water and a water heater in order to act as both an insulator and as a heat source, and then also to keep the compost moist and the air humid within the bin. And then in the 20-gallon sized container, we created this PVC pipe mixture that had some holes drilled in it that we are planning to use to aerate the compost and then mix it around to keep the nutrients and feedstock balanced. So I see the time is up. If we just go quickly to the last slide, it's just a visual of what PLA looks like as it's breaking down. And then looking forward, we will be adding, oh, sorry, back 1 slide. We're looking forward to starting the initial trials of our compost and tracking the temperature to make sure we can get up to that 140 degree limit. And then of course, a thank you to the partners from 3M who've helped us get started with this project and provided us some ideas. So yeah, any questions?
Yeah, it looks like that composter is heated externally, like there's energy inputs into it. Is that the case?
Yeah.
Yes. Mm-hmm.
Okay.
So at this point, our main problem really is raising and maintaining that temperature for a long period of time, and especially when we're trying to do things based off of at-home materials. That really is kind of the main issue here. At this point, we did just buy a cheap heater, water heater, So I think it was around $30-$40. So we're hoping that that would be a little bit more accessible to people, but that really is what we'd work on over time. For example, we suggested even solar at some point or something like that, but we're not quite there yet. Yeah, I see Beth mentioned that too. So we're not quite to solar, but it was definitely just an eventual step that we're hoping to take.
Well, and I'm wondering if Beth means not necessarily a solar panel, but like a, you know, if you've seen solar cookers, so some sort of greenhouse type effect.
Yeah. So at this point, we were just seeing kind of with our overall like bin design, if it could even get up to those temperatures. And then once we've checked that everything is kind of working the way we want it to, that was kind of the next step, was adjusting that for sure. Yeah.
Maybe solar thermal as well could be considered. It's a very interesting presentation. Could you go back a slide? I'd like to see the PLA as it's degrading at the temperatures. I think you had to jump over that really quick.
Yeah, one more backwards. There we go. So
Yeah,
this wasn't technically,
think...
oh, sorry, you go, Catherine.
Oh, I was just gonna, yeah, I think what you were about to say, Lita, this is from an outside study that was done that it just examined what PLA looks like as it's breaking down. But one thing that was interesting and that we saw in our initial trial runs is that the PLA turns from a clear color into this whitish, more opaque color. I think is a sign of hydrolysis occurring, which is kind of how the microbes will break it down. So we kind of observed that in our trial runs that were in the oven. So we kind of have that idea for what we hope to see as we check back in with our compost design.
So you're looking at,
go ahead, Ken.
So you're looking at deploying, if you were able to deploy this, say, in a residential setting for a single home use or maybe multifamily?
Yep. So at this point, we use like garbage bins and things like that. So hopefully that would be something, different tubs people would have lying around in some way.
I would imagine there's also temperature limitations on the higher end too, right? That if it gets too hot, of course, you kill the microbes. So yeah, kind of how big a band is that?
Not too big, I don't think. I think it's around getting above 160 degrees Fahrenheit, I think is kind of upper limit. So for us, at least, so the water heater that we purchased has a timer and a dial. And I think it'll be important for us to be able to time it correctly so that, as you said, the heat doesn't get too high, or even if we need to open up the lid to let some heat out. And so that'll definitely be a large part of the next stage when we track the compost with the temperature probe and hopefully get a reading every day to see how the temperature spikes.
And when you were doing your in-lab experiment, how long did it take from the start to breakdown? I think you said, but I think I missed it.
With us, it was a pretty qualitative experiment, but within 1 week when we opened it back up, the PLA it was hard for us to find any of the PLA that was left, which is pretty exciting, but we did cut it. We took a cup and then cut it into strips. So I think a large part of the PLA breakdown is that it does need that. Well, not a large part, but the initial part, it needs to just break down mechanically into smaller pieces. So we kind of helped with that process. So it'll be interesting to see if we placed just a water bottle in, like in this picture, how that might affect the timeline.
For example, in industrial settings, it's a few weeks, maybe 2 months or so. Obviously, that's a much bigger scale. So, but we're hoping for kind of an extended thing like that, like a few weeks or so.
Are you also looking at the increase in just the composting cycle for non-PLA products like your food scraps alongside the plastics?
You mean, are we studying like what happens to that as well?
Yeah, just any increase in composting times for all of the materials entering that system.
I guess as far as I know, we weren't really, but that is maybe a good point that we should be keeping track of adding more materials around it or seeing even the environment around it just to make sure that's consistent. Just for testing, as far as that goes, we were doing short enough trials that we weren't seeing a huge difference. But I think with our first now, as we're getting started, we're starting this weekend, the longer trial that we're doing with the big composter, that will definitely be something to look at.
And so you mentioned that there's the heating element, and then Catherine, I think you were also saying that you have an aerator, or is it an actual turner? So is it being turned mechanically, or do you have to go in and turn the compost yourself?
So that you have to go in and turn the compost yourself. We just created this PVC pipe that has arms sticking out and then drilled holes through that. And then the top part of the arm just opens to the atmosphere. And then we have a little handle we could put on to turn it. So I'm very curious how that aspect will work out. That's kind of the design that we thought might work. We took some of that from 3M to those contacts, had used something like that. So we'll be able to tell, I think, a lot by the smell if it's anaerobic versus aerobic decomposition. So that should be clear. But yeah, I think it's just an interesting project because with aerating, if we add more air in, that's obviously more exposure to the outside, which might lower the temperature. So there's just it's been very interesting to try to design the different components to all work together.
Awesome. Thank you guys very much for that presentation.
Yeah, it's very good.
Thank you.
We are going to, we're going to move on now to Abby Hornberger.
Hi, everyone. Just wait for the slides to show up. So my presentation today is going to be a little bit different than other people's. This is more about some personal activism that I've been doing in my daily life. I'm a senior at the University of Minnesota Twin Cities, studying environmental science, policy management, and sustainability studies. And since I moved here to Minnesota from the Chicago area, I learned a lot about Line 3 and what that means for our future, and have been involved in fighting this through the legislature, which has been happening for about 7 years now. And ever since construction of Line 3 was approved in December, the rate at which they have been constructing is extremely fast, and I felt compelled to get involved in direct action, both in the cities and up north. So you can go to the next slide. So I just wanted to give a brief overview for those who might not be familiar with the plethora of issues that are in existence with Line 3 about why it shouldn't be built and why there is no future for fossil fuel infrastructure, as many of us can recognize and know today. We do know that pipelines always leak. There are many faulty ways that pipelines, they're installing pipes that have cracks in it, pipes that have rust on it because they've just been sitting out in the weather during this long legislative process that we've been fighting it through, which directly threats our very clean water resources here in Minnesota, which I know we all love and value a lot. And it, also is a direct threat to land and wildlife because we don't know how to effectively clean up a tar sands oil spill. There's no scientific way to ensure that it's cleaned up in its entirety. And we see this through the example of the Kalamazoo oil spill that Enbridge did not clean up when that happened. As I mentioned before, we also know, many of us in this room know, that there is just simply not enough time in the climate crisis to be building more fossil fuel infrastructure. The need, which has been talked very heavily about in the Minnesota court system, in my opinion, just doesn't exist. We can't continue to pour billions of dollars into something that is quite literally running us into extinction. Additionally, the missing and murdered Indigenous women and relatives issue is very pressing. There was a sex trafficking sting that was caught, I believe, a couple months ago up in Minnesota, and at least a few of those people involved were tied Enbridge workers. And this happens because workers are forced to live in man camps where workers typically foster, a culture of drug, alcohol abuse, misogyny, and racism. And the Indigenous communities that live by and the women that live in very close proximity to where these man camps are subjected to very high levels of violence. And it somewhat goes undocumented because no there's not enough knowledge of this issue. However, on the bright side, I did know that Deb Holland is dedicating almost an entire task force to this missing and murdered Indigenous women and relatives, or sometimes called Two-Spirit people, which is inspiring to me. And then while Enbridge is rerouting its site to move off of Indigenous lands, the small little reservations that they do have left, this is still problematic because most of northern Minnesota is part of the 1855 treaty lands. And it still causes mass destruction of untouched, pristine environmental areas and ecosystems. And so also this can be drawn back to the land back movement of really respecting Indigenous sovereignty and respecting their cultural sites. Many of these women have to watch where they grew up learning to become women. That is just ruined. So there's many reasons why Line 3 is an issue that go beyond just ecosystems. It also has very deep ties to Indigenous sovereignty. You can go to the next slide. So these are some photos from how I've been involved. I'll just walk through each of them and sort of what's going on there. In the top left, there was an event thrown down by MN 350, which went to the Army Corps of Engineers to demand a stop to Line 3. Also, we also focus on calling out the major funders of the pipeline, like Chase Bank, Wells Fargo, a lot of those big banks that people very frequently use fund these projects very heavily. And there has been some success there. However, they are still kind of greenwashed grants that allow these projects to be continued being built. I have spent some time on the front lines. I can tell you that it's very devastating. It smells like destruction and death on those work sites. And it's really a painful process to watch all of that be destroyed. In the bottom middle, you can see I gave public testimony at the Public Utilities Commission about a year ago before COVID started, which was like one of the craziest times for me. It was like right before, and I just remember that being really monumental for me. And it looks like my time's up, so you can go to the next slide, which just this is a little bit about what I've learned, but you can go to the next slide one more time. And then these are some Indigenous groups that you can follow who are led by matriarchs, Indigenous leadership, and they are leading the frontlines resistance. So I believe this is an issue that any Minnesotan should care about because it directly threatens our land, our water, and Indigenous sovereignty. So that's all I have today. Thank you.
I just want to say thank you for your work and efforts on this and for bringing a social justice lens to environmental issues. It's really important.
Yeah, and I find that that's something that is missing from my education a lot. I have been a bit frustrated by the fact that I study this. And sorry, I get a little bit emotional when I talk about it, but Line 3 wasn't taught to me. This is something that I taught myself outside of the classroom. And that's frustrating because this is our ancestral homelands of Indigenous people, of the Anishinaabe people. And I wish that it was more addressed at a university-wide level. And I think that there's great work that is being done at IONE and at a lot of the sustainability initiatives. There's a great course, as Beth is putting in the chat. Environmental justice is an amazing class that I believe I think that lots of students should take it. And I know that there's efforts, but I know that this is one way that we really should put our talk. We should take action because all this talk isn't stopping the pipeline, unfortunately. And while we all are here to acknowledge that fossil fuel infrastructure doesn't have a future, we need to really make sure that this doesn't happen in our backyards, in our state right now.
Abby, thank you for your presentation. I thought it was very well done. Can you speak to what has inspired you to get involved in this effort?
Yeah, I grew up going to a camp in northern Minnesota, so I just spent a lot of time on the boundary waters and in that pristine wilderness, which I acknowledge is a great privilege. And my mother was very inspirational to me when I was young about fighting for environmental justice. And so when I came here and I learned about this, I was like, we'll put a stop to this before it actually happens. This isn't going to happen. And unfortunately it did. And so I couldn't sit back and watch all this mass destruction happen without doing something about it myself and putting my body on the line, because for far too long, BIPOC communities have been the ones holding all of that responsibility. And we see that to this day with the killing of Dante Ray. And so it is very difficult to have two major social justice issues going on in Minnesota at the same time. And I think that that's something that we should really address at a systematic level, because obviously the state has systems of mass oppression happening at a very local level. And I know this is like a very difficult thing to be confronting as people who are settlers on this land. And it is very uncomfortable for most people to confront, but I do appreciate everyone for being here and for listening. And I encourage everyone to get involved with some sort of decolonization work, because there's a lot of justice to be served there.
Thank you, Abby. I'm just going to echo what Beth put in the chat, that we just need to keep talking about it and keep getting it out there and make it the thing that we are talking about. Just appreciate that a lot. And we're talking a lot in sustainability of the overlapping issues of racial justice, and that is quickly becoming the more central focus than just reducing emissions. It's how do we help people, and in so doing, the other things will come together too. So appreciate you. Thank you very much.
Thanks. I was also going to echo something that Beth put in the chat about, this is adjacent to every other pipeline in the country. However, one thing that's unique about Line 3 is the direct threat to wild rice, which is sacred. And wild rice only grows in these waters. It doesn't grow anywhere else in the world. So that is like something that's completely unique. I forgot to put that in the earlier slide, but yeah, that is one thing that we really couldn't ever get back if these waters were destroyed.
Yeah, just again, thank you very, very much for this presentation. It's always really important to see environmental justice included in the sustainability talks. So that was our final presentation for this session, but we do have the panel coming up, which, connecting to what Abby was talking about, is highlighting Indigenous voices. And so that will be at 3:30. No,
2:30.
2:30. There we go. And that will be happening in this room 1. So Fatima, are we going to do a break until then?
Yeah, thank you all of you for presenting, and thanks to all of our judges for being here and taking out the time to listen to the presentations. We have about like 20 minutes of wait time, so yeah, good time to go and